to the Ada Lovelace Day podcast. I'm Sue Charman-Anderson, and this month I'm talking to software developer Elen Gwynne, who's going to talk to us about how she made the transition from astrophysics to programming. And we've got theoretical physicist and broadcaster Professor Jim Al-Khalili OBE, who'll be telling us about Daphne Jackson, the first woman to become a professor of physics in the UK. So this month we're talking to Elen Gwynne, who is a computer programmer. Hi, Ellen.
Hello.
So, Ellen, you're a computer programmer now, but that isn't your background. Where did you start?
So I started I studied astrophysics at university. Always assumed that would be my life. So the classic degree, PhD, postdocs, onwards to professorship and Nobel Prizes. And then I got an introduction, very basic introduction, in the second year of my course to programming. Discovered that I quite liked it. It clicked instantly in my brain, and sort of it all fell into place after that. Without too much work, I got very lucky.
So what was it about astrophysics first that really attracted you?
I grew up with a family that always did science museums when we were kids. My dad did an astronomy degree, so we always had that connection. He bought a telescope when I was 11. I grew up with Star Trek and Star Wars and sort of all the different science fiction. I just wanted to be that person that went into space and sort of explored the unknown. Then discovered that was probably quite unlikely to actually happen, and that there was far more interesting stuff going on if you stayed on Earth and used the telescopes to see what was going on. So then I sort of changed direction slightly from astronaut to astrophysics.
How did you find the astrophysics degree? I mean, how well did the degree marry up to what you had imagined it would be?
The degree was perfect. I really enjoyed doing the degree. It was probably more maths than I had expected going in, for even things that don't really seem like you would want maths. I expected maths for the quantum stuff, but there's a lot more in other areas that I wasn't expecting the depth. But I still really enjoyed doing that, and I certainly wouldn't change my degree option. If I had to go back to being 17, 18 and choosing university courses, I would absolutely go back and do astrophysics again.
When you started computer programming in the degree course, kind of what form was that? What were you doing with the programming?
The first course was very basic, just introduction to programming in Java, sort of object-oriented, very basic conditionals and really simple problems to solve, but how you could set them up so a computer could do it, and very shallowly covering that you could then have computers doing far more complicated versions of this where a human wouldn't be able to solve them on their own. And then in third year we had a slightly more computer programming for physics module, where it was much more setting up a solar system and modelling gravity and how orbits would change if you changed parameters slightly, that kind of thing. And those were really the only two compulsory modules for our degree. But then later I was able to take even more specific astrophysics computational ones, where it was flow of particles, sort of really focusing in on the different ways you would model really large simulations of bodies.
And what was it about that you enjoyed so much?
I think a lot of it was the simplicity of computers. They follow your instructions. It doesn't matter if you tell them to do something stupid, they'll do their best to do it. And sometimes it will completely fail and fall over as soon as you try to run it. But I like that simplicity of just, I'm telling you to do a thing, you go do that thing. There wasn't sort of complications, and my mind really worked well for setting out problems in the ways that the computers could understand and that I could put down in code so that the computers could run it.
So did you have like a sort of a moment where you suddenly kind of thought, this is actually what I want to do?
I think it was when I did summer placements. I applied to a scheme, the Leicester University Shore programme, and it was with the School of Astronomy, but the project I ended up working on was very much computer programming based one. So it was image analysis via code, so that you could just set it running to look through millions of images without a human having to spend all the time on it. And I spent, I think, 6 weeks, 8 weeks just solidly programming 9 till 5 every day. And at the end of 6 weeks, I wasn't hating doing that. And I thought, people pay me for this. This could be a career. I could do this long term.
Excellent. So not hating it was a good start. So you finished your astrophysics degree. Was the first thing you did after university to try and get more training, or to try and get a job in programming?
So I knew I wanted to spend 6 months after university just at home, enjoying my time again after doing a 5-year degree. So I didn't really go into looking for jobs straight away. I'd applied for a couple during my last year, but hadn't had any success. So in that 6 months, mostly I carried on playing around just in my own time. There's a lot of resources online that I just experimented with, had fun playing around, didn't really put any directed effort into it. And then once I got to the end of that 6 months, it sort of became more, so there was a stronger feeling of what do I need to do to be more employable. And then while looking for jobs at the same time, I was looking at requirements a bit and seeing what places wanted.
And when you found these requirements, what did you do to make sure that you met them?
First jobs, a lot of the requirements are sort of fairly basic knowledge of the programming language. They don't mention in-depth details so much. So it was mostly, I made sure I was happy with the programming languages that I was putting on my CV, and played around a bit beyond that with the different structures that are around for storing data and for manipulating data, just playing around with the different things, seeing what was around, so that if something that wasn't mentioned in the job description came up in an interview, I could mention it as I've seen this. I think this is the kind of situation it would be useful, but I don't know for definite.
When you were working on this, sort of preparing for applying for jobs, did you get any help in this? Did you get any careers advice or join any programming groups for the languages that you use, or sort of programming groups for women?
Not really. I mean, there are a lot of very good groups on Reddit that I followed, but mostly I didn't need to post questions. I found all the resources just by finding the right search terms to Google. So mostly I just did it completely independently. I knew a handful of people from university who had done computer science and informatics degrees who I could ask if I got really stuck on something, but that very rarely happened. Mostly it was finding the right terms to search, and Reddit and Google provided most of what I needed.
Looking back, I mean, do you think that it would have been helpful to find a group of peers to join, or to sort of join something like BCS Women? Was that something that you think might have helped, or do you feel like actually Google is perfectly sufficient?
For me, for learning the languages, enough to do stuff with the language, Google was sufficient. There are things like algorithms and programming patterns that are harder to pick up via search terms when you're stuck. And I think if I had had a group of people who were learning in a more structured sense, I'd probably have picked those up better. And then that makes, when you're programming a big thing, having those makes it much easier to keep track of the code, keep things organised. It's nice having other people going through the same problems at the same time as you. So even though I did fine at the learning of the language, it can be nice. And I possibly would have benefited from having other people going through it that I could talk to and sort of whinge about programming languages or share ideas and suggestions.
And there, of course, there's huge amount of courses that you can do. I mean, there's things like Code Academy and Treehouse and all of these websites now that teach programming from scratch. If you'd not been introduced to programming and learnt so much at university, do you think you would have tried those kinds of sites?
Yeah, I think I would have done. Certainly, I tried Code Academy for, I think, both Python and Java, and what I saw of them, they seemed like very good courses. I think my problem was because I already had some knowledge, I think at the time there wasn't a way to easily skip the very basic introductions. So I found the first few courses a bit frustrating and didn't carry on working through it. But I think for someone coming from scratch, I think they would be a very good resource.
It's rather like sort of human languages, I've got kind of good basic Welsh, but the idea of ploughing through a beginner's course in order to get to an intermediate course would drive me up the wall, I think. So then you got a job as a software developer. That is now your career.
Yes, or at least 3 years into the career, so we'll see where it goes from here.
The thing that always strikes me with my career has been, the stuff that I have done didn't exist when I was at university. So, I did my degree in geology, and social media at that point in sort of the very early 90s, it didn't exist. It's very hard to project forward for anyone now because the pace of change is so much. But do you see yourself kind of staying as a developer for the foreseeable future?
Yeah, at the moment that's very much what I want to stay in. I mean, languages and details might change. Things come in and out of fashion, but definitely I want to stay with the computer contact.
And I think the other thing that there is a bit of a perception when we talk about computer programming and technology, and we tend to focus on the startups. So women in tech is like who's CEO, founder, CTO of their own startup, but actually there's a lot of opportunity in technology in a traditional career, in getting a job working for somebody else's business. Do you feel like there's some people in tech kind of look down on that a little bit?
I think I wouldn't want the risk of I wouldn't have an idea to start a company in the first place, but I think I wouldn't want to take on that risk of not knowing if I was going to have a company in 6 months' time. So I think I'm very happy to stay within sort of established companies, or at least reasonably secure companies, and like do the day-to-day, just making sure the business carries on running work. I've never quite got the temptation of the startup as a perfect goal for life as a programmer.
Yeah, I mean, having had my own startup, I can vouch for the insecurity of it and the stressfulness of it. And, the thing that we often overlook, that the media often overlooks, is the fact that most startups in any field will fail. And they will fail, within the first 2 or 3 years. And I do get a little frustrated when people view tech only as the startup world, because there is a vast array of career opportunities, and this is good, satisfying work. It's not it's not settling for second best to have a job in someone else's company as a programmer.
Yeah, I mean, if you run your own business, you have to do all of the other managing the business stuff, and I mean that just doesn't appeal at all to me.
And I think rightly so, because as someone who runs their own business, it is really, really tedious. I think sometimes there can be a bit of an all or nothing culture and around technology and programming, especially that there's this attitude in some quarters that if you're not sort of programming 24/7, you're not a real programmer, and I mean, I obviously think that's a nonsense.
Yes, definitely an attitude I've run into on the internet. Thankfully not so much in real life. Everybody I've met through my work has been very similar attitude to it to me. This is a job. I go home and I have other things that I want to do, and I like what I do for my job, but I have other things that I like doing too. But it's definitely something that I've found online, where if you're not programming in a specific style, if you're not sticking your brackets in exactly the right places, you're deemed as not real, an amateur.
Yeah, and I think that attitude puts a lot of people off programming, but I mean, there is I think a hardcore group of voices that we hear over and again, particularly online, and we don't hear so much from people who really enjoy programming and enjoy their work, but it doesn't fill every second of their waking day.
Yeah, I think that's a fair point. I don't see many people ignoring the fact that I'm a woman in programming, which is a fairly rare beast as a starting point. I don't see many people who are just in programming as a job presented as being the standard programmer, even though 90% of us are like that. Everybody wants to focus on the rock star programmer.
Yeah, there is a real stereotype, and it doesn't represent the industry. It doesn't represent what the career is actually like, and I think it puts people off. It certainly kind of would put me off, you know, that idea of I have to be one of these people that just, you know, takes monotasking perhaps to an extreme. But you're talking about, you know, women in tech. It's you are in a minority. Are there things that, in your experience, tech companies and companies that have tech departments could do to make life a little bit easier and make the culture more welcoming?
I think, speaking from the experience of my two jobs, mostly they've been very welcoming environments. I've not had any issues where I've thought that I was being mistreated for being female. So it's a very jokey atmosphere, which some women might not like. It's a style that I get on with, but I can perfectly understand why the tenor of some of the jokes might put women off. But I think mostly I've been very lucky. I've found places that have similar styles to the way I work. And both of the jobs I've had, they've been very welcoming to working from home when needed, which obviously makes a big difference if you're having to look after kids who are ill at short notice. I think the main thing is just the not seeing people like me. There's a few women at both jobs, and the numbers are growing as the companies employ more people, but I'm still aware when I walk into a room that it's very heavily male dominated still.
I think there is an argument to be made, though, that when we look at, again, the technology industry, it's not monolithic. There is this sort of startup side to things, and then there is this sort of industry side to things, if you like. I mean, the difference between a startup and an established business is quite vast. And there is that, again, we don't really hear so much about what it's like working just within a normal software department within a bigger company. We tend to hear a lot more about issues around startups and access to funding and attitudes within very, very small businesses, many of which are just fundamentally insecure places to work because of the nature of being a startup. And I feel that, you know, we're actually, with our focus on startups, we're maybe putting women off exploring other sections of opportunity within the very, very broad environment that is technology and industry.
Yeah, I think startups have you don't go home. You might go to your house, but you're still working until 2 a.m. and then you're back at the office at 7 a.m., which is absolutely not my experience. I mean, even in crisis programming times when something's gone drastically wrong, I've never known anyone put in that level of hours. And that's the standard story with startup and focusing on startups as the main programming sector. If people are expecting it to be 7 a.m. till 2 a.m., catching a couple of hours sleep, that's not at all my experience, but it's what is presented as the main programming options.
Well, it's been really interesting hearing about your experience of switching from astrophysics to programming, and also kind of, you know, to start to think a little bit more broadly about what a programmer does, what kind of person is a programmer, and what kind of opportunities are available, because I do think the media does quite a big injustice to the kinds of careers, the variety of careers that are available in programming. So thank you so much, Ellen. It's been a real pleasure talking to you.
Thank you for talking to me.
Thanks to Ellen for taking the time to talk to us this month. Our podcast is made possible thanks to the generous support of ARM, our exclusive semiconductor industry sponsor. You can find out more about ARM's energy-efficient microprocessor technology on their website at arm.com, and you can follow them on Twitter at ARM Holdings. If you'd like to join ARM as a co-sponsor of our podcast, then please email me at suw@findingada.com. Now it's time for Discovery of the Month, which this month is more of an invention. In fact, it's an invention that makes this very podcast possible. The software that I'm using to record it, the software you'll use to download it and listen to it, every app or program you use depends on this invention. Yes, this month we're talking about the compiler. Now, you might have heard of programming languages such as C, Java or Ruby that software engineers use to tell computers what to do. These languages are designed so that they're easily understood by humans, but computers themselves speak a very different language called machine code. Machine code is not very user-friendly, and writing programs in it would be difficult and tedious. So instead, programmers write in easier languages, then translate the results into machine code using a compiler. Now let's go back in time to 1951 and the Universal Automatic Computer, or UNIVAC-1. Like many other computers at that time, the UNIVAC was programmed directly using punched paper tape. And just like modern software, programs for the UNIVAC often reused sections of code called subroutines. Usually, those subroutines would be punched into the tape every time they were needed. But one person had a very different idea for dealing with subroutines. A mathematician called Grace Hopper came up with a much more elegant solution. Instead of copying them out every time they were needed, Hopper collected all of the subroutines that she'd written over the years and put them onto a single tape. Each subroutine was identified with a call number. So instead of having to laboriously copy out the code, all Hopper had to do was write down a set of call numbers. Hopper didn't like repeating the same task over and over, so to her the compiler was an obvious solution. Sadly, others weren't quite so keen on her innovations. "I had a running compiler," she said years later, "and nobody would touch it because they carefully told me computers could only do arithmetic, they could not do programs." Despite its usefulness, it took a few years for Hopper's compiler to become more widely accepted. But that wasn't Hopper's only innovation. She suggested as early as 1949 that computers could be programmed using English words, another of her ideas that was dismissed. She went on to write Flowmatic, the first data processing language to use English keywords. Flowmatic, like most modern languages, also depended on a compiler to translate it into machine code. Commander Grace Hopper worked with the Navy until she retired in 1966, aged 60. She was, however, recalled to active duty less than a year later, retiring again in 1971. That retirement didn't last either, and she was recalled once more in 1972 and was promoted to Rear Admiral in 1985. She finally fully retired, involuntarily, in 1986, aged 79, at which point she was hired as a consultant by DEC, a position she held until her death in 1992, aged 85. I would like to suggest that we all say a little thank you to Rear Admiral Grace Hopper every time we use software that's been compiled. But if we did that, we'd never get anything else done. Joining us now is theoretical physicist, author and broadcaster, Professor Jim Al-Khalili OBE. Hi, Jim.
Hello there, Sue.
Now, I'm sure a lot of our listeners will know you because of your broadcasting work, and perhaps especially The Life Scientific on BBC Radio 4. And for that, you've interviewed some amazing women in STEM, people like Jocelyn Bell Burnell, Helen Sharman, Julia Higgins. And I think more than anyone else I've spoken to, you know a lot about the achievements of women in STEM.
Yeah, I mean, that's one of the nice things about the Life Scientific. It's not something that we set out deliberately to do, but we've got into this rhythm now where exactly half of my guests are women. And it really isn't the case that we're saying, oh, there's all these great men scientists that we have to sort of, they're all queuing up, but we've got to somehow find a woman to make sure that the gender is balanced. We are finding great women scientists and engineers, and there's a lot of them out there. There's really no excuse for not to be celebrating women's achievements in science and STEM in general as there is men. We're proving that with the Life Scientific.
It absolutely sure. I found that with the podcast. My list of potential interviewees is years long. I mean, it would take me a long time to get through them.
Yeah, I mean, in fact, only today I recorded another Life Scientific with a woman called Sadaf Faruqi, who's a professor of nutrition and metabolism, and again, it's not someone people will have heard of, but these are people who have made a contribution to humanity that I think we should all know about.
Absolutely. So who have you chosen to tell us about today?
I gave this a little bit of thought, but actually the decision was quite easy. I've chosen a woman called Daphne Jackson, Professor Daphne Jackson, who was a professor of physics. In fact, there are many reasons why I've chosen her and why she is special. But for me, she was head of my physics department at the University of Surrey, where I still work today, when I was a student. And she taught me in fact, mathematics during my second year of my undergraduate physics degree. She was the first woman professor of physics in the UK. She was appointed a professor at the very young age of 34, I think, back in the early 70s. And for about 15 or 16 years, she was the only female professor of physics in Britain, which just goes to show how awful a situation that was. And hopefully we're starting slowly to address that.
Now, regular listeners are going to detect a theme here, but I was trying to do a little bit of background reading and really struggled to find a clear description of her research other than it was in nuclear physics. Tell us a little bit more about her research.
Yes, so luckily enough, after I got my degree in physics at Surrey, I then stayed on at Surrey working in Daphne Jackson's nuclear physics research group to do my own PhD. So I'm very familiar with that part of her research career. So this field within nuclear physics that she specialized in is called nuclear reaction theory. So in physics, you can broadly divide physicists into the experimentalists and the theorists who do the mathematics, the equations and the computer programming. Daphne Jackson was a theorist, and she studied the way atomic nuclei react with each other. So it's not simply somehow peering inside a nucleus and seeing how its constituent particles, the protons and neutrons, all arrange themselves according to the laws of quantum mechanics. No, she was looking at how a nucleus of a particular atom slams into a nucleus of another atom, and what happens next. Do they break up? Do they bounce off each other? Do they sort of fuse together? So nuclear reactions is a way of actually understanding the structures. We sort of do that even in particle physics. You slam things together as hard as possible. So at the Large Hadron Collider, you slam two beams of protons together, just smash them at the highest energy you can and see what it makes. In nuclear physics, it's a bit more finessed, and you try and bounce these nuclei off each other at very special energies and see what happens. So Daphne Jackson's work was all about knocking nuclei with protons and neutrons and knocking out little fragments of a nucleus, other protons and neutrons, because by knocking bits out, that tells you how they were arranged inside the nucleus. So it's a way of looking inside the nucleus of an atom by smashing it with another nucleus.
How is this research used? Why is it important?
Well, it comes in lots of different ways. So, of course, certainly there are applications, for example, in medicine, in nuclear medicine, and this is something that Daphne herself went on to work in, the applications of nuclear physics in medicine. So, an example now, for instance, is the way we're developing what's called ion beam therapy. In order to treat tumours, you rather than just flooding the body with poison, basically chemotherapy or radiation, X-rays, for example, you actually target a tumour with a beam of atomic nuclei, carbon or just individual protons. So in understanding how a nucleus interacts with the nucleus of another atom is vitally important. We know we want to deposit this energy from this nuclear beam exactly targeted at a tumour and not destroy all the surrounding healthy tissue. So hugely important in medicine, but also actually just in fundamental blue sky research. So just to understand how all the atoms are made and cooked, all the atoms that make up our bodies were cooked inside stars. So how do stars shine? How are the elements synthesized? In order to understand how elements are cooked in stars, we need to understand the nuclear reactions. And I remember there's a famous quote actually by another colleague of mine at Surrey. He said, when you look up at the night sky, almost everything you see is the result of a nuclear reaction. So all of astronomy, all the stars and galaxies, so all the processes that go on in the heavens, if you zoom in close enough, you'll see it's down to a nuclear reaction. So studying how atomic nuclei react with each other is vitally important in understanding how the universe itself was built up.
It's kind of amazing when you put it like that, actually. It's it's not a way I normally think of the night sky, but I will do from now on.
It's very poetic. I mean, sometimes people say, oh, we're all stardust. Nuclear physicists say, yeah, we're all nuclear waste, which is somewhat less poetic, but probably more accurate.
But I think what's interesting for me is that when we think about nuclear physics, well, certainly my mind goes in one of two directions. It's either nuclear power or it's the Large Hadron Collider. But this is another sort of branch of nuclear physics that maybe doesn't get quite the same level of attention in the media, perhaps?
I think that's right. Certainly, nuclear power, and even to even more negative extent, nuclear weapons is a legacy of nuclear physics where I think for many years nuclear physicists were even sort of rather embarrassed about using the N word, because if you say you're a nuclear physicist, very often people would assume, you must be either building bombs or creating nuclear radiation or whatever, nuclear power. Certainly, I guess particle physics, so the stuff that goes on at the Large Hadron Collider, that's zooming in into the building blocks of matter that is even greater in detail than nuclear physics. So you can imagine, trying to figure out what everything's made of, and you realise everything's made out of atoms, and you say, well, actually, the atom itself has got inner structure. It's got electrons going around a nucleus. Let's look at the nucleus. You look at the nucleus, it's made of protons and neutrons, and let's see how they interact, and that's nuclear physics. Particle physicists, those who work at the Large Hadron Collider, are looking inside the protons and neutrons themselves, at the even tinier constituents, the quarks that make up the nucleus. So, in a sense, yes, particle physics has become, I guess, a little more sexy because many people will see it as, more fundamental in some sense. We're looking at the ultimate building blocks of matter. But nuclear physics, I mean, it's really down to sort of how big a magnifying glass you want. Understanding how the atomic nucleus is built up is hugely important because 99.9+% of all the stuff that we see around us, and all stuff being made of atoms, is in fact residing in the atomic nucleus. Because what else is there? There's just electrons orbiting around it. Electrons are tiny. Nuclear physicists just ignore electrons. They don't even exist as far as we're concerned. Chemists hate that because the whole of chemistry is what electrons are doing. But nuclear physicists don't care. They're tiny, they're light, they're irrelevant. Let's look at that heavy, tiny nucleus in the middle. That's where all the fun happens. And of course I say fun because it's all down to quantum mechanics. And for me, that's the fascination. Quantum theory, the theory of the very small, is so weird and wonderful. And the atomic nucleus is the playground of quantum mechanics.
And in terms of our experience of nuclear physics as individuals, actually it's in medicine where most of us will come face to face with nuclear physics. And it was at the Royal Marsden and Cancer Research Institute where Jackson worked on nuclear imaging.
Yes. Nuclear imaging, what used to be called nuclear magnetic resonance. But because of the negative connotations of the N word, the nuclear word, nuclear magnetic resonance, NMR, became known as MRI, magnetic resonance imaging. So now we talk about MRI scanners, but actually an MRI scanner is basically doing nuclear physics, and it's nuclear physicists who invented it and now know how to use it. And Daphne Jackson was one of the pioneers of nuclear medicine back in the 70s and 80s.
Now, you mentioned that she was the UK's first female professor of physics, but she didn't just stop at a professorship, did she?
No, she became the youngest professor of physics and the only woman professor of physics in the UK for many years. She was head of the physics department at Surrey. She then went on, she was the youngest ever fellow of the Institute of Physics. She became a vice president of the Institute of Physics. She received an OBE for her contributions to promoting STEM in general. And she sat on an incredible number of, we were amazed by her energy. I remember as a student in the 80s at Surrey, and Daphne Jackson was just a force of nature. She was so influential in so many areas in promoting science, in talking to government, in getting connections. And I guess her legacy, most importantly, is in promoting the cause of women in STEM.
Indeed, and obviously that is a cause close to my heart. Can you tell us, what was it that she did for the women around her?
Well, I remember when Daphne was head of the physics department, there were so few women, certainly in physics academia. She was the only female in the whole department among close to 30 academics. So you might say, well, what did she do? She got to the top and then it was, she didn't care about those coming up behind her. She was aware that one of the main problems, apart from, any the difficulties women had into breaking into a very much a male-dominated world of engineering and physical sciences, which to a large extent it still is today, women found it very hard to get back into research careers, particularly if they wanted to take a career break for family reasons. If women did their PhD and maybe did a few years of research, and then reach an age in their 30s when they wanted to start a family, fine. Now it's hard enough for anyone to break off from a research career and then get back into it again. You've got to catch up with what's been going on in the field while you've been away. There's all this publish or perish idea. But for women to get back into it after having a family, it was many times more difficult. And I remember Daphne saying once that imagine a society that would allow someone like Marie Curie to just stack shelves in a supermarket just because she wanted to take a career break for family reasons. What a waste to humanity that would be. And so in the mid-80s she set up this new trust, and is now called the Daphne Jackson Trust, which is now it's broadened out, so it's not just women. It's helping anyone come back into research in STEM subjects after a career break. Now it could be for family, it could be for health reasons, it could be because you've been having to act as a carer for someone in your family. For whatever reason you've had a career break, the trust provides these fellowships that people apply for that can get them back into research, and that's been hugely successful to this day. And she started it in the 1980s, and this year I believe it's celebrating its 30th anniversary.
It's fantastic, and it's also a really important model. I know that there's a major problem in engineering with again a lot of people, predominantly women, taking career breaks and then struggling to get back into industry. And the fellowships, they look really supportive. Having read through the Daphne Jackson Trust leaflet about the fellowships, it's not just about, we'll get you back into research. It's also very supportive.
Yes, I mean that's the nice thing about it. You don't just simply apply and if think you qualify. They say, right, okay, here's some money. You can you can take this money and go and work somewhere. They're there supporting you all the way. I mean, it's really sweet. I mean, it's the Daphne Jackson Trust still operates. It has its main office just round the corridor from my own office in the physics department at Surrey, and it is like a family there. The atmosphere is that they really look after these fellows, and even though the numbers are growing every year, I think they've currently got well over 100 fellows who are benefiting from the trust. They're managing to keep it the closeness and intimacy of, but really helping these people on a personal level.
Because at the end of the day, it's not just about what you know, as they say, it's also about who you know, and having that network of support and mentors. It's quite often I see programs that are focused on young women and giving them that kind of mentorship, but actually it's something that we kind of all need throughout our careers. It's not just for new graduates.
No, I think that's right. I mean, and particularly, for women who want to forge a research career, and it is tremendously competitive. You graduate, get your degree, go on to do a PhD, maybe then go on to do some research. But then when you get to the point where you're looking for a permanent position, or you're setting up your lab and you're building a sort of a research network, very often that is the time when women want to also be starting to have a family. And the idea that you have to choose, that if you choose one, that closes the door on the other, is just a ridiculous notion. But these are incredibly smart people who've done all the legwork that you need to do to make it as a research scientist or engineer, and then somehow you're sort of waving goodbye to that career simply because you want to take a 2 or 3 or 4 years career break to have children. It's harder in academia and in research than it is probably in any other career, being able to sort of pick up the pieces again after you've taken a break, because you've got to catch up on what you've missed out. The science and research has moved forward, and having these fellowships gives people that just a breathing space, I guess, to catch up, to get back to where they were before, to where they left off.
And academia, of course, is quite famous for not being hugely good at flexible working hours. To put it mildly, and I think, which is something that affects men as well as women. But I think what I like and appreciate about the fellowships is that they support part-time research, so that it's not this kind of, right, we're going to throw you in at the deep end and off you go. That if you have just had a family, then having a part-time opportunity actually is really important to have that level of flexibility.
And also, being part-time doesn't mean that you're going to be half as useful, because very very often there are many people coming back into their careers where, as you say, that is the only way they could operate, and it's all or nothing. I've certainly interviewed many women on the Life Scientific who have made tremendous contributions, real groundbreaking, world-leading research, because they were able to have that flexibility of having a family and a research career, and that's the thing. This idea that you would close the door, that these people would not have been able to do what they did if there wasn't this flexibility, is ridiculous. So hopefully things are changing now. Hopefully universities certainly are realizing that they are really cutting off their nose to spite their face if they're not allowing some of their brightest researchers to get back to doing what they were doing in a more relaxed, in a more appropriate arrangement than the sort of 100%, hell for leather sort of research where nothing else seems to matter. There are other things in life.
Absolutely. And I have to say now, I'd not heard of Daphne Jackson before you mentioned her, but she has this amazing legacy, not just the fellowships, but also all of the research that she did and laying the groundwork for the medical imaging that we now kind of take for granted a little bit.
Absolutely, and she really was a real presence. I mean, sadly, Daphne died at the age of 54. She died of cancer, in fact, in a disease that she was working, doing in her research to try to fight. So she was cut off in her prime. But I remember her, walking around. She'd be walking around the physics department with her handbag. This is at the time of Britain under Margaret Thatcher. Famously a woman who ruled over men. Well, Daphne Jackson was far nicer than Margaret Thatcher, but just as scary. I mean, if Daphne Jackson was walking down the corridor, you sort of smartened up your. She really was an incredible energy. That she really did so much. She published books. Even now, when I've got a new PhD student working in nuclear reaction theory, who started in October, and one of the first books I gave him as background reading was Daphne Jackson's Nuclear Reactions textbook. It's a standard in the field. So she really was a giant on the international field of nuclear physics as well.
Fantastic. Well, thank you so much for telling us about her. It's been a real pleasure talking to you.
Thank you very much.
You can find out more about Jim on his website at jimalkhalili.com, or you can follow him on Twitter at Jim Al-Khalili. Jim's also got 2 new books out: Aliens, Science Asks, Is Anyone Out There? And Quantum Mechanics, a Ladybird expert book. We've got links to those, plus links to A Life Scientific on Radio 4 on our blog. Now, if you're a woman looking to return to research after a career break, please do take a look at the great work that the Daphne Jackson Trust are doing. Again, we've links to their website in our show notes. Thanks once more to our sponsor, ARM, for their ongoing support. If you'd like to join them as a podcast sponsor, please do get in touch. Thanks also to our editor, Andrew Marks. Don't forget you can subscribe to our podcast on iTunes, Google Play and Stitcher. And of course, please do rate and review our show. Now, before we go, you might like to know about a new project that we've just launched. We're publishing crochet patterns for amigurumi dolls of women in STEM. Our first pattern depicts astronaut Dr. Mae Jemison and is available for free download from our website at findingada.com. Next month, we'll have all the Sues. I'll be chatting to nanochemist Dr. Suze Kundu about how she's using nanostructures to extract energy from sunlight. And Dr. Sue Black OBE, the founder and CEO of Tech Mums, will be talking about her tech heroine. So thank you for listening, and we'll catch you next month.